Hello, everybody. My name is Donovan. So this session is about to discuss the data security in that AI-powered actuarial workflow projects for MIGA rate setting. A very big disclaimer at the very beginning of this video. The information that's shared in this session is by no means to be comprehensive. It captures my personal opinions as well as demoing a bit of experiments on my end. Okay, so let's begin. The very first thing that I kind of learned in this project is that I think that the view of data security in terms of where the responsibility falls on needs to change in the era of AI. The old model was that the security has always been the IT's problem. We have dedicated security and risk teams to define the rules, develop and build features, and hand off to a security gate at the end. There's clear boundaries, clear ownership, but a lot of gaps in between. But with the emergence of AI, the cost of being able to code independently and develop has decreased significantly. With that being said, everyone now can develop new code and applications interacting with AI systems. At some point, we need to start recognizing that everyone at that data boundaries has a role. It's no longer the IT team, the data teams, or the risk teams owning this data security responsibility. It's shared in between different functionalities there. Policymakers document the rules, risk teams define classifications, developers implement them in code. So a lot of time, the developer itself has to be trained well enough to understand the data security concepts as well as implementing the right structures that align with the policies or the rules. So just kind of a little bit to understand why there is that data security issue in the era of AI. If you're looking at the example of an AI tool, a natural language and AI tool like ChatGPT or Claude Code, basically what's happening is your files is being read by Claude Code and is sent through a API context window and then sent to the Cloud API, and the Cloud API return a response. So in the entirety of that process, through the API, Claude Code itself or the company whoever develops the Claude Code now owns the data that you fit in. Hypothetically, if we're fitting 500,000 policies in there with their policy ID, names of policyholders, as well as the date of birth, right, PI, personal identifiable information there, it becomes a bigger issues. These informations are now stored, at least read and received by cloud, and then you can never even control that these data is actually being used to train a new model or so. So that would cause a pretty significant data security issue. So with that being said, understanding that API data flow framework, we start building this kind of learning experiment of how we can implementing a data security structure in this AI augmented workflows. So this project takes a pragmatic approach, implement controls where we can, observe what breaks, and iterate. The key philosophy behind the entire work is that things continue to work until they fail, and our job is to reduce blast radius. And for this project in particular, I have looked at three different aspects of this, which are repository boundaries, defines where AI can access data, where they cannot, raw data isolations, how to stop AI from touching the raw data, execution whitelist, how to stop AI from using tools to access the data. Let's start from the first one. Rule number one, repository boundaries. this kind of this corresponds to a scenario where the AI tool is not only permitted to interact with the files in your project repository, but also anything in your computer. With Claude Code, you can easily ask him, well, what's in my downloads folder? What are the information in this CSV file in my downloads folder? Claude Code would have no issue reading that and give you the explanation or answer. So being able to set up a repository boundary ensures that no absolute path to external locations. Why it matters? With a lot of projects like this, AI agents could theoretically access any files on your account. For example, credentials, SSH keys, other project data, system configurations. Those are typically stored outside of the project itself. The way how we do it through cloud.markdown file and then settings and hooks in the cloud configurations, which we'll look at a little bit later in the demo. Rule number one, raw data isolation. This is a place where you define what data is considered confidential and untouchable. We'll call raw data by unreadable by the AI. If a tool call tries to access them, the permission system generally just denies it. So in this project in particular, we have kind of added a few folders in there: data raw folder, data sensitive, output sensitive folders. The ways to do it is you can actually implement a permission criteria, a permission deny list in the settings.json file in Claude Code. The last item is execution whitelist. Well, even though we have a limit Claude Code itself to not touch in a file in that raw data folder, you can't really stop a Claude Code to write a Python scripts to get the first 5 policies or first 500 policies out of that scripts and send out the outputs of that back to the Cloud API. So the whole idea of execution whitelist is that it only allows Cloud to run a predefined agent scripts that you have written and you have designed in the system, other than allowing him to run any arbitrary Python share commands that can scan directories or scripts that read raw datasets. In terms of how it's been enforced, it is actually enforced in this hooks functionality features in the cloud. Without further ado, let's look at the project itself as example. We can actually start by testing that the 3 data security structure that we ever implemented. I mean, ask the first question. Can you tell me what's in the policy 200 data.csv file in my downloads folder? This is kind of testing that the first item called what we call boundary. So by inputting this question, you would expect that the AI would say, well, I cannot access the files in that repository because it fails the rule number 1, which is a repository boundary. So next, what we're going to do is I'm going to ask the AI to directly access this file called policy data CSV in the data raw, which is has been flagged as a sensitive data or confidential data, which AI should not have direct access to. Show me the first 10 records in policy data.csv. So by asking that question, the AI would respond that he can't access this file because it's restricted under rule number 2 that we have defined. The last one we'll do is that, can you write a script, a Python script that populates the first 10 records that populate. Well, let's try something that we do have access to. This outputs folder renewal compiled. Populate information in renewal compiled 2027 Q3 .json. without further without a second, AI would answer that they can't because it is limited. That we're not allowing the AI to write a script that reads the database to populate the file, which violates the rule number 3, which is the execution whitelist. So this is kind of quick example of demonstrating that these rules that we set actually works in terms of where to set it. In the .cloud itself, there's a place where we called settings. I'm just gonna close this for now, which you can add permissions to define what is being denied. For example, to read, edit, write certain folders, and then there's a separate section called hooks, which kind of defines some other policies or rules that we made in there. And if you look at the hooks itself, the guard files itself would contain all those different security rules that we have in there. Part of it is to establish repository boundaries. Part of it is for raw data isolations. For example, the restricted directories here. Part of it is to specify what execution whitelists are. For example, these are the patterns that we are blocking, and these are the patterns that we're allowing. In particular, with Python, we only allow in Python to run agents, scripts that we have defined in agents, rather than any sorts of the scripts that we ask AI to randomly generate it and perform. So this is kind of a quick example of how I was able to implement some partially of the data security structures with the code. Now we have look at kind of 3 different ways to address this data security issues, partially address the data security issues. What's next? There's still a few things kind of in my mind to be looked at. Number 1 is data classification labels. With a lot of in a lot of insurance companies, there are standards that's being applied to all sorts of folders. HIPAA data, PII data, confidential data, internal data, public data. Is there a way to do that with any of the data that's being used in this AI workflow to assign them with a label and apply the right policies there? The second one, automated in-force testing. There's no automated test suite that verifies the security rules work. So a boundary violation test script would catch regressions before they reach productions. So basically making sure that you design an entire automated test to check each of the security rules you have defined actually work. And that is crucial for the purpose of setting up data security guardrail. Third one is large language model output auditing. This is something that can keep track of the outputs from the AI agents so that you can really look at, well, what's being sent to through the API to the AI agents and what's being returned there. You can even add additional layer to classify or to capture these outputs by HIPAA policies or PII policies. And the last one is granular agent permissions. In this project in particular, we kind of sets all the agents to have similar or the same permissions with data. But in realities, these agents we define, some of them might need to have different access granted. For example, the data retrieval agents should have access to the remote SQL server, remote database, the data warehouse. But then your email agent probably shouldn't have that. But again, security is a journey. Those controls are a starting point. The important thing is that the boundaries exist and we know they're there. And like I mentioned a little bit earlier, things continue to work until it fails. So being able to constantly experiment and challenging ourselves with the mindsets of securing the data is crucial in this journey of AI development and AI deployment. And last but not least, this is my contact information. At any time, if you have questions, feel free to reach out, and good luck.